Hello friends. For the last 11 hour session, we were discussing various concepts associated with the matrix algebra. Today, we are going to explore one of the important application of matrix methods in economics in particular and social science in general, namely the concept of input-output analysis or the input-output model. Welcome to the session. The analytical tool of input-output analysis was popularized by economist Vasily W. Leontief. So it was popularized and invented by the Vasily W. Leontief or W. Leontief in his work in the year 1930s. And in fact, input-output analysis is also known as the Leontief's input-output model, because being popularized and invented by Vasily W. Leontief. And he won the Nobel Prize in economics for his contribution of this particular analytical tool. Now, what is the meaning of input-output analysis? Today in our session, we will be basically looking at the meaning of input-output analysis. What are the implications of input-output analysis? What are the assumptions of the input-output analysis? And we will also show hypothetically an input-output flow table. Hopefully, in our subsequent session, we will explore how to solve input-output model by using our familiar matrix method. That's where lies the importance or the application of matrix algebra in social science for solving the input-output model or the Leontief input-output model. So, the model was invented by Vasily W. Leontief in his work in the 1930s. Now, what is input-output analysis? The input-output model essentially focuses on the interdependence of sectors, or what we call there is a circular interdependence among the sectors of any economy. That is, the economy can be thought as a composite entity of different sectors which are interdependent or interrelated sectors. So, this interrelationship, this mutual interdependence are empirically studied by using the tool of input-output analysis or input-output model. Here, input means the raw material, the resources needed for a producer or for an entrepreneur for his productive activity, while output implies the net result or the outcome of any productive effort. So, as we all very familiar, input means the resources, the raw material required for the productive activities, and the outcome of the productive activities is nothing but the output. So, a relationship between input and output, or more specifically, an empirical analysis of interdependence between various industries or various sectors in an economy. Because Leontief pointed out that an economy can be thought as different sectors which are interdependent. How they are interdependent? There is a relationship, because many sectors and industries, in fact most sectors and industries, will be using the output of other sectors as input. And the output of their output will be used by the other sectors as their input. So, there is a relationship between different sectors in an input-output way. So, there is a circular interdependence, there is a circular interrelationship, there is a mutual dependence, there is a mutual interdependence. There is a relationship and an interdependence, and this mutual interdependence, this interrelated sectors, this interrelationship between different sectors, this relationship between different industries or sectors are empirically analyzed and explored by the input-output analysis. Now, there may be a situation in which one particular industry may not be using the input of other sectors. And there may be even a situation in which the output of one particular sector is not used by other sectors, or it directly goes to the final demand or for final consumption. But still, even though it may be the circular interdependence or circular interrelationship, this mutual relationship between different sectors are a fact, and in fact is more common in or most common in most of the economies. So this relationship between different sectors, this interrelationship between different sectors, this interdependence between different sectors, this mutual relationship or mutual dependence between different sectors are verified and explored by, analyzed by the Leontief's input-output model. So that's basically the meaning or the implication of input-output analysis. Now, let us just focus on what are the important assumptions of this model, because the input-output model rests on some of the simplifying assumptions. So what are the important assumptions of the model? The first assumption of this model is that the economy is divided into n interdependent sectors. So there are interdependent n number of sectors, because we can easily extend the 2-sector, 3-sector model into n number of sectors. So there are, the first assumption of the model is that the economy is divided into n interdependent, interrelated sectors or industries. That's the first assumption of the input-output model. The second assumption is that there is absence of joint products. There is absence of joint products, we call it as GPT. And also there is absence of substitutability. So as per the assumption of the model, there is no substitutability of inputs, as well as there is no joint products, in the sense that one industry produces only one particular product or one particular output using a one particular input structure. So there is no substitutability between inputs, and there is the absence of joint products. So one particular industry produces only one particular products. So that's the second assumption. And the third assumption is, which is very important assumption as well, we call it as the proportionality assumption. The proportionality assumption in the input-output analysis is very important, because this assumption is used for solving an input-output flow table. We will see flow table today itself, and the subsequent session we will see how to solve an input-output flow table. Now, the substitutability, also the proportionality assumption, which is the third assumption, says that the input, for example, let me just put it like this. Let me define, well, let me just remove this Leontief as well as the interdependence. Let me just put it as Xij. X designate output. Xij means the output of ith sector, which is used as an input in the jth sector. That is, Xij means output, X denotes the output of the ith sector, which is used as an input in the jth sector, will be proportional to the output of the jth sector, or we can write it as this is equal to some proportion that we call it as Naij Xj. The output of ith sector, which is used as an input of jth sector, will be proportional to the output of jth sector, will be a function of the jth sector. For example, the output of agriculture, which is used as an input of industry, will be proportional to the output of industry. When the output of industry increases, the demand for the input will increase. So it's Aij. Here we introduce a proportional coefficient, Aij. Aij is assumed to be fixed. Aij is known as the technological coefficient. It's also known as the structural coefficient or input-output coefficient. And Aij is assumed to be fixed. So the proportionality assumption, that's a fixed proportion. That's why the input-output model assumes a fixed proportion production function. And once we draw the isocont for input-output model, we will get an L-shaped isocont. This is the shape of isocont in an input-output model, because it's an L-shaped isocont, implying there is no substitutability between factors. There is a proportionality assumption. So this L-shaped isocone or kinged isocone resembles a fixed proportion production function, implying there is absence of substitutability of factors. So xij equals aij xa, and aij, which is what we call the structural coefficient or a technological coefficient, is assumed to be fixed. So that's the third assumption. And the fourth assumption of the model is that there is constant return to scale. There is the presence of constant return to scale. And that means if aij increases in a given proportion, xj also will increase in the same proportion. There is a constant return to scale. We have the assumption of no technical progress. There is no technical progress, which is the fifth assumption. And we have the sixth assumption is that the output of one particular sector is either used as an input of some other sector, or it goes directly for the final consumption. That is, the sixth assumption is that the output of one particular sector goes as an input of some other sector, or it goes directly for final consumption. That's the sixth assumption. So there is no technical progress, we have a constant return to scale, and aij is obviously fixed. That is, we have a fixed proportion production function. So input output coefficient, what we call aij, which is a technological coefficient or a structural coefficient, is assumed to be fixed. So we have a fixed proportion production function. So these are the important assumptions of the input output model as well, because assumptions are important, because these assumptions, especially the third assumption of the proportionality assumption, will be used for solving the input output flow table. Now, having explained the meaning as well as the implication of different assumptions of the model, now let us just hypothetically present an input output flow table. So we have an input output flow table, and we will see what are the important relationship in input output flow table. Now let us just explore the input output flow table for a two sector case. Okay, we have an input output flow table for a two sector or for a two industry analysis, in which we have two sectors, namely the agriculture as well as industry. So we have a two productive sectors of agriculture and industry, and they use each other's input for their production process, and also they use the services of labor. So we have agriculture as for sectors or industries. You can call industries as sectors also, because both are the same. So we have the two sectors, namely agriculture as well as industry, and we have the labor service as well. So the total output or total production, since we are talking about input and output, the total output of agriculture is 250. The total output of industry is 120. The total labor service available is 50. Now, let us decompose these total output into different kind of input. Now, out of the 250, which is the total output of agriculture, 25 is used as agriculture sector itself as its input. 175 is used by industry as its input, and 50 goes for final consumption. So, out of 250, out of the total output of agriculture, a portion is used by the agriculture sector itself as input. Another portion is used by industry as input, 175. Obviously, a portion is used for final consumption or for final demand. So, final demand we have 50. So, 25 plus 175 plus 50 equals 250. So, total output is disbursed. That's as per the assumption of the model. The output is either used as input by some other sectors, or it is used for final consumption or for final demand. That's with respect to the output of the agriculture. Now, let us explore the output of industry. Industry produces 120. Out of this 120, 40 is used by industrial sector itself as input. 40 is used as input in the agriculture sector, or agriculture use the 40 units of industry as its input. 20 is used as the input in the industrial sector itself. 60 is used for final consumption. So together they constitute 120. So out of the entire production, entire output of industrial sector, a portion is used by agriculture sector as input. In our case, it's 40. A portion is used by industrial sector itself as input, we have 20. 60 used for final demand or final consumption, so we have 120. Now, total labor service is 50, in which 10 is used by the agriculture sector, 40 is used by the industrial sector. Obviously, you cannot directly consume the labor service, that's why final demand is 0. So, there is a relationship, right? There is a relationship between input and output when we saw a case of a two-sector example. Now, let me just make things a bit more clear. Let me just call agriculture sector as the sector 1 and industry as sector 2 and labor service as sector 0. So, I can write this as what is this? The output of the first sector. So, first sector is agriculture, right? The output of the first sector, which is used as the input in the first sector itself. Using our proportionality assumption, this is nothing but X11, right? Output of the first sector, agriculture, output of the first sector, which is used as an input of the first sector itself. So, I have X11 here. Here I have X12. Output of the first sector, which is used as an input in the second sector. And final demand, let me just call it as F1. So, total output is X1, which is the output of the first sector. We call agriculture as the first sector, right? So I will have this kind of a relationship, what is known as the balancing equation or structural equation in input-output model. That is the equation is something like this. That is X11 plus X12 plus F1 is equal to X1, right? With the rest, that means total output of agriculture sector is X1. A portion is used by the agriculture sector itself. We call it as X11. A portion is used by the industrial sector or the second sector as their input. We call it as X12. A portion goes for final consumption or final demand. I have F1. So, all these constitute X1. So, similarly, I can write it like here X21. Output of the second sector, which is industry. Output of the second sector, which is used as an input in the first sector. What is 40? The output of industrial sector is used as an input by the agriculture sector. So, I have X21 here. I have X22 here. And this is, let me call it as F2. Together they constitute X2. Output of, so the output of industrial sector, or in our example the second sector, is used as an input in the agriculture sector, is used as an input in the industrial sector itself, and is used for final consumption. So, I have this equation, right? X21 plus X22 plus F2 equals X2. The second balancing equation, the second structural equation in input-output model. And finally, we have what is known as the labor service and labor service. Let me just put it as X01. Here, X02. Here, we can just write it as X0, which is nothing but the labor service, total labor service. So, total labor service is used as an input of agriculture sector, which is X01, which is used as an input of industrial sector X02 plus 0 obviously. That means we can also write it as X01 plus X02 plus, here again we have a 0 here, equals X0. Clear? So, we have three balancing equation from our input-output model. We can also see some interesting relationship, right? See the diagonal elements, right? See the diagonal elements, these two elements, or we can have these two. These X11 and X22, what is the implication of these two output? That means these two are the output of a sector, which is used as the input of that particular sector itself, right? We can also find another relationship. X1, which is an output of the agriculture sector or the first sector, is a function of input 25 agricultural input, 40 industrial output and 10 labor service. In fact, these three constitute, these three inputs produces the agricultural output. That means the input structure, the column entries are the input structure, right? The input structure of agriculture is 25 in agricultural output, 40 industrial output and 10 labor. That means these three inputs in fact produces the agricultural output of 250. Similarly, these three 175, 20 and 40, or x1 to x2 to and x02 produces 120, which is x2, which is the output of industrial sector. So we can argue that x1 is a function of, we can write it somewhere here, let me just put it here. So x1 is nothing but a function of these three, x11, x21 as well as x01. Similarly, x2 is a function of x12, x22 as well as x02, because these are the input structure for producing or for realizing this output. So, by using our proportionality assumption, from our proportionality assumption perspective, we can rewrite our balancing equation. Like x11 can be written as a11x1 plus a12x2 equals, plus f2 equals x1. Similarly, we can rewrite x21 as a21x1 plus a22x2 plus f2 equals x2. So we can rewrite our structural or balancing equation from our proportionality assumption using input-output coefficient or a structural coefficient. x11 can be written as a11x1 plus a12x2 plus f2 equals x1, and similarly we can write it as a21x1 plus a22x2 plus f2 equals x2. From this balancing equation, we can solve for input-output model by using the terminology propounded or in fact popularized by the matrix methods. So how to solve a matrix method in a 2-sector or a 3-sector, or how to solve an input-output model in a 2-sector or a 3-sector model will be explored hopefully in the next session. Hope that this basic introduction of input-output analysis, its meaning, assumptions as well as the implication of a flow table, how to describe a flow table is useful to you. So next session we will try to explain how to solve an input-output model. So until we meet next time, stay safe, happy learning.